Section 8.5 is called Using the Distributive Property. Beginning with this section, we're going to start factoring the polynomials that we created in the previous sections when we were multiplying. So factoring is breaking down an expression into its factors. That is breaking it down into the parts that it multiplies to. What we're doing is basically undoing the multiplication. An example that you're probably very familiar with is the fact that the factored form of the number 12 is 2 times 2 times 3, because that's what you get when you multiply those numbers. So 2, 2, and 3 are the factors of 12. So one method of factoring some polynomials is to use the distributive property in reverse. So for example, if we have the quantity 3x times the polynomial x squared plus 4x plus 2, you remember we distribute that 3x to each term in the polynomial, and we get 3x cubed plus 12x squared plus 6x. Basically what factoring is undoes that. It goes backwards. So it takes the polynomial 3x squared plus 3x cubed plus 12x squared plus 6x, pulls out the greatest common factor of 3x, and leaves you with what's left in the parentheses. So basically factoring using the distributive property is undistributing. So here's some steps. First thing we need to do is identify the greatest common factor of the terms in the polynomial. What can each term in the polynomial be divided by? We put that greatest common factor outside the parentheses, and then take each term inside the parentheses, each term in the polynomial, and divide it by the greatest common factor. Whatever is left stays inside the parentheses, and you can always check by distributing. So if I distribute that greatest common factor to every term in the parentheses, do I get back to where I started? So let's take a look at several examples here. So number one, we have 5x squared plus 10x. The greatest common factor in this case is going to be a 5, because both the 5 and the 10 are divisible by 5, and an x, because I can take an x out of x squared, and I can take one x out of here. So my greatest common factor is 5x. So that goes outside the parentheses. And now I divide each term in my original polynomial by this 5x. So 5x squared divided by 5x gives me an x. 10x divided by 5x gives me a 2. Another way to think of this is, what do I have to multiply 5x times to get 5x squared? And what do I have to multiply 5x times to get 10x? So my final answer is 5x times the quantity x plus 2. And remember, you can check this by distributing. 5x times x gives me 5x squared. 5x times 2 gives me 10x. Let's take a look at example number 2 here. I have 5a squared b minus 15a squared b squared minus 5a squared b cubed. So let's start with the numbers. The largest number that I can take out for my greatest common factor is a 5. And here I have an a squared, an a squared, and an a squared, so each of those terms can be divided by an a squared. And here I have a b squared, and a b cubed. Each of those can be divided only by a b. Notice I can't divide b squared by b cubed because that's too many b's. So my greatest common factor of 5a squared b will go outside the parentheses. Now I need to take each term in my original polynomial and divide it by 5a squared b. Well, this is a little tricky here because my first term in the polynomial is 5a squared b. But when I divide those, I get a 1. Don't forget to put that in there. There needs to be kind of like a placeholder there, you know. So when I go and distribute, I actually can get a 5a squared b. Now, dividing my next term, negative 15a squared b is going to give me a negative 3b, because 15 divided by 5 is 3, a squared divided by a squared is 1, so I don't have any a's left. B squared divided by b is b. And my last term, 5a squared b cubed, is going to give me a negative, and then the a squareds divide b squared. So my final answer is 5a squared b times the quantity 1 minus 3b minus b squared. And remember, you can check. So if I multiply, I get 5a squared b, 15a squared b squared, a negative 15a squared b squared, and a negative 5a squared b cubed. Now, another way to deal with this is sometimes you have a polynomial that has 4 terms, and this can be factored by grouping. And to be honest, this is one of my favorite ways to factor. I think it's kind of fun. So what we're going to do is notice we have 4 terms here in my first example, 4ab plus 8b plus 3a plus 6. There is no greatest common factor. I can't divide everything by 2. I can't, each term doesn't have an a or a b. So there is no greatest common factor in all 4 terms. So I'm going to start by grouping the first 2 terms together and grouping the last 2 terms together. So I'm going to look at this first set of pink parentheses as a polynomial unto itself. What can I factor out of this? What can I undistribute and take out of this? Well, I'm seeing a 4 and a b, because both of those terms are divisible by 4 and b. And when I factor that out, I'm going to be left with an a and a plus 2. I can check. 4b times a gives me 4ab. 4b times 2 gives me 8b. Perfect. Now, take a greatest common factor out of the second set of parentheses here. 3a plus 6. I can take out a positive 3. Don't forget to put that plus there. And that's going to leave me an a plus 2. Now, it is no coincidence that I have exactly the same thing in the parentheses. That is actually a factor of my new first term and of my new second term. So what I'm going to do is basically factor the a plus 2 out of each term. So each term has an a plus 2, and what I'm left with is 4b plus 3. That's how we factor by grouping. So I've grouped the first 2 terms together, the last 2 terms together, taken a greatest common factor out of each one, and what I'm left with in the parentheses, if it's the same, then that means that that is a factor of both the first term and the last term. So if you wanted to check this, you can't really distribute. I guess it is distributing, but you'd have to FOIL this and you will get back to where you started. Let's take a look at another example here. 3xy plus 15y. I will group those together. And a negative 4x minus 20. I'm going to group those. I'm going to grab that minus, put a plus up there, and factor out a greatest common factor out of each one of those. So out of 3xy, I can take out a 3y, and that's going to leave me with x plus 5. Out of my second set of parentheses, since it starts with a negative 4, I'm going to factor a negative something out. And actually it is a negative 4 that I could factor out of there. And that's going to leave me with an x. Now this is a little tricky. Negative 20 divided by negative 4 gives me a positive 5. And again, I have the repeated factor of x plus 5. So I'm going to basically factor that out of each term. And that leaves me with 3y minus 4. And remember again, you can check this by foiling, multiply, and you should get back to where you started. And the last concept we're going to take a look at here is called the zero product property. And this is a way to solve equations. So it basically says if the product of 2 factors is 0, then at least one of the factors must be 0. In other words, if you're multiplying 2 things and they multiply to a 0, then one of those, at least one of those, must be 0. So here's a way to show it with letters. If a times b equals 0, then either a equals 0 or b equals 0 or both a and b equal 0. Basically, you cannot multiply 2 numbers and get a 0 unless one of them is a 0. And we're going to use this to solve equations. Example number 1. We have the 3x times the quantity x plus 10. So one way to look at it is here's one term and here's another term, and those two are being multiplied times each other. So either 3x equals 0 or x plus 10 equals 0, because up above we have 3x times the quantity x plus 10, that equals 0. So one or both of those has to equal 0. So we're just going to solve this like a simple equation. Remember that 0 divided by anything is equal to 0. There's one of my answers. And then subtracting 10 on both sides here, I get x equals a negative 10. And often with these you will get 2 answers. So my 2 solutions are x equals 0, x equals negative 10. Remember what that means is that when I plug in 0 for x, the equation works. When I plug in negative 10 for x, the equation works also. And our last example here is 20x squared minus 15x equals 0. What I need to do first in this case is to factor this. So I'm going to take out a greatest common factor out of each of these of 5, because both of those can be divided by 5, and an x. That's going to leave me with a 4x and a minus 3. So you can check that by distributing. That's going to give me a negative 20x squared. That's going to give me a negative 15. Now I have the quantity 5x times the quantity 4x minus 3, and that equals 0. So that means 5x equals 0, and possibly 4x minus 3 equals 0. Dividing both sides by 5, I get x equals 0 as one of my solutions. So adding 3 to both sides, and then dividing by 4, I get x equals 3/4. So again, I have two solutions, either x equals 0 or x equals 3/4. So this is how you can use the distributive property to factor polynomials, and then use the zero product property to solve